Introduction to measurement system, first slide I have shared. Visible?
Yes, sir.
Fine.
Sir, visible.
Yeah, good. I have changed the network, so I'm using mobile hotspot now. So now let's start. We had discussion about introduction to measurement system in the previous lecture. Yesterday also we started, but because of technical problem, we could not continue. But now we are revising and then we are moving ahead. So first of all, in the measurement system, we already discussed that there are different elements. So there is a physical sensor which actually measures and come in contact with the physical parameter which you need to measure. And then you have some signal conditioning circuit to which you convert that physical parameter in terms of some electrical signal. And then there is a data representation block, which may be a kind of a record or a kind of a display, right? So this is the basic block diagram about which we had detailed discussion in previous lecture as well. Now, after understanding this, we had this part. What is basically difference between sensor and transducer, right? What are the different blocks in signal conditioning unit? So we have A to D converter, we have amplifier, we have filter, then we have rectifiers or maybe modulators. So these are the different blocks maybe there in the signal conditioning unit. And data representation device may be LCD display, maybe a kind of a scale, kind of a recorder, right? So these are the different blocks available. I also give you example of a transducer with the help of some temperature measuring device like RTD, right? So RTD is basically a sensor, but when you convert it into a distance bit, you have signal conditioning circuit. So together it behaves as a transducer because it will give you change in temperature with reference to change in electrical quantity. Okay, so this is the basic example of transducer. We also discussed about classification of transducers, right? So in classification of transducers, we discussed about different categories: active, passive transducers, then analog digital transducer, then primary, secondary transducer, and direct and reverse transducer, or we can say inverse transducer. So these are the four main categories in which we classify the transducers. And in depth, we had discussion about first two categories, that is active and passive transducer. So as already we know that active transducers do not require actual power. So they are by default active, right? So kind of thermocouple is a kind of active transducer, and passive transducers are the transducers which require actual power source, right? To convert that particular quantity or parameter. That is a passive transducer. We also discussed about analog and digital transducer. Analog transducer will give you signal uh, varying with time, right? So those kind of transducers are analog transducers. Thermocouple is a kind of analog transducer. Digital transducers are those transducers which give you discrete signal as an output, right? Those are discrete transducers. We talked about different types in that, right? So basically, we had example when I put here the tacho generator or something that is basically a digital transducer. I think first two categories we discussed a lot in detail. Now we can move ahead. So just a minute, let me just share these analog and digital transducer. And is there any doubt in this four categories? First फोर टाइप्स जो हमने डिस्कस किया, एक्टिव, पैसिव एंड एनालॉग डिजिटल, उसमें कुछ डाउट है तो हम आगे बढ़ सकते हैं. Everyone, please respond. Good, no doubt. So we can move ahead. Let me share the next content. PPT is visible at a, I have changed the PPT. Is it visible properly?
Yes, sir.
Fine. Now we are moving ahead about primary and secondary transducer. That is the next category. So I told you that when you use two transducer in combination, then one transducer will be a primary transducer and another will be the secondary transducer. So for this particular example, we can see here, if you see, basically there is a burden tube. Burden tube is a kind of elastic element, right? अभी इसमें क्या हो रहा है? You insert the pressure inside the burden tube. Abhi, because of that, what will happen? The burden tube is actually having some kind of a curved section, but because of that pneumatic signal or because of external pressure which you are exerting inside the tube, it will try to be straight. तो जब बर्डन ट्यूब स्ट्रेट होने का ट्राई करेगी यहाँ पे, बिकॉज इट इज इलास्टिक एलिमेंट, इट विल ट्राई टू बी स्ट्रेट. तो उसके साथ थ्रू फुली यू आर कनेक्टेड वन, वी कैन से दिस इज बेसिकली एलवीडीटी. तो एलवीडीटी में क्या होता है? प्राइमरी एंड सेकेंडरी कॉइल्स होता है. So because of that, what will happen? This internal core जो है, it will move vertically, either up, either down. So because of that, the primary winding है आपका और secondary winding है. Primary winding has a constant voltage source, and it is in the secondary winding the induction will be different. So because of that induction, your voltage induced will be different in the secondary coil. So you can see here our burden tube is not capable of generating electrical signal. So it is just a primary transducer, which is just providing some kind of a change in its shape based on the change in pressure. And according to that, you have connected that out uh, end to the core of the LVDT. So LVDT basically मैं आपको डिटेल में समझाने वाला हूँ, but अभी हम प्राइमरी एंड सेकेंडरी समझ रहे हैं. So for that you can get the idea. We will also understand burden tube and other elastic elements like bellow I told you last time. So we have different elastic elements that we'll be studying in the pressure transducer section. And similarly in displacement measurement also we study about LVDT. But अभी हम खाली एक example समझने के लिए we are taking this reference. So primary transducer is a transducer which is not capable of converting the state of electrical form. So we are using primary plus secondary. So at the end you are getting secondary electrical signal. So यहाँ पे primary transducer है, it is your burden tube, and the secondary transducer is your LVDT. All of you are clear?
Sir, could you please repeat on how does the change in burden tube causes a change in EMF or output voltage?
देखो बेसिकली क्या होता है, burden tube is actually curved section in initial phase. अभी आपको it's a hollow inside. So when you insert air in it, because of that it will try to be straight. तो जो वो जब स्ट्रेट होगी उसके एंड पे है कनेक्टेड कोर ऑफ द एलवीडीटी थ्रू पुली. आपको दिख रहा होगा वहां पे. यू कैन सी हियर एट द
Yes.
एंड वी हैव कनेक्टेड कोर with the help of pulley. So because of that deflection, right, either pressure कम हुआ तो it will again be curved. अगर pressure ज्यादा हुआ it will try to be straight. So because of that there will be linear motion or say vertical motion in this core of the LVDT. और आप यहाँ पे तो सिंपल समझ सकते हैं प्राइमरी से सेकेंडरी में induced voltage will be different because of the position of the core, right? So this is basically combination of primary plus secondary. So primary transducer is burden tube and secondary transducer is LVDT. Am I clear?
Yes, sir.
Fine. So this is the in every case we don't require primary plus secondary combination, but in few of the cases where your primary transducer is not capable of converting in the form of electrical signal, then you will also use some secondary transducers. So LVDT is also one of can be used as a secondary transducer. Okay, shall we move ahead? Primary, secondary is clear to everyone. Please writing
Sir,
platform. हाँ बोलो.
sir, yeah, this burden tube which you are talking about, sir, in that when the pressure is applied, so it is just changing its shape, right?
Yes.
So, sir, why are we calling it a transducer?
It's not a transducer. It is a pressure sensor. But together the combination behaves as a transducer. So the primary part of this transducer we are considering as a primary sensor or primary transducer, and secondary is a transducer. Together this is a combined combination. So together it will give you electrical signal. So it is converting pressure signal in terms of electrical output. So that's why we are calling it as a combination of transducer.
Okay, sir.
Fine. So after understanding the third category, let's move to the next classification. Now we are discussing about direct and inverse transducer. We talked about active passive. We talked about second category was analog and digital. We talked about primary and secondary. The fourth category is direct and inverse transducer. Now this is also one of the major category. अभी आपको इसमें नाम से ही पता चल रहा होगा. Few of the transducers are converting non-electrical quantity into electrical quantity. That is called direct transducer. Thermocouple is a kind of a direct transducer. But when we have inverse operation, so inverse transducer changes the electrical quantity into non-electrical quantity. Maybe any non-electrical quantity. That is called as a inverse transducer. राइट. इनवर्स ट्रांसड्यूसर जो है वो इलेक्ट्रिकल सिग्नल लेके नॉन इलेक्ट्रिकल में कन्वर्ट करेगा. डायरेक्ट ट्रांसड्यूसर्स जो है दे विल कन्वर्ट नॉन इलेक्ट्रिकल टू इलेक्ट्रिक. So basically, if we understand, transducer will convert one form of energy to another form of energy. So when we have direct electrical output, then it is direct transducer. When it is using electrical output to generate some non-electrical output, then it is inverse transducer. Am I clear? ये simple है category सबसे. Please write in chat box. Yes, great. So thus we have classified the transducers in 4 different categories, and that is an overview for you to understand the classification of transducer. Now, after understanding about classification of transducer, we are moving to the next topic, right? So the classification of transducer was your first topic, और अभी हम बहुत ही important topic पे जा रहे हैं, that is static and dynamic characteristics of an instrument. Okay. So before going in this, we already had some basic idea about the terms accuracy, precision, then error, then any doubt, then ask me straight away because मैं chat box को भी read नहीं कर पाऊंगा in parallel with the discussion. You can ask me question if you have doubt.
सर मतलब इनवर्स ट्रांसड्यूसर का एग्जांपल एनालॉग एमिटर्स ऐसे होंगे.
Yes, very good. Analog emitters है, I2P converters है. I2P converter is using electrical signal and converting in pneumatic. It is one form
And
of yeah.
so current carrying coil in magnetic field is also an example of inverse
Yes.
transducer.
Yes. Sometimes, for example, you are using crystal. Crystal को आप microcontroller you have studied, right?
Yes.
So in microcontroller you are using crystal. The crystal को supply electrical signal and it vibrates. It is also one form of inverse transducer.
Okay, sir.
तो वो क्या कर रहा है, इलेक्ट्रिकल सिग्नल को वाइब्रेशन में कन्वर्ट कर रहा है, कन्वर्टिंग वन फॉर्म टू अनदर. It is also one form of inverse transducer. Am I clear?
Yes, sir.
That you are raising the different points so that you can get clear idea, right? So it's very important to understand transducer in detail, at least different terms, right? Okay, shall we move ahead in characteristics? Fine. So before going into characteristics, we are already familiar with the basic terms, so we will be having different characteristics mainly classified in 2 parts, static and dynamic. Okay, अभी मैं static, what we are going to study in this presentation, पहले तो सबसे पहले what is the difference between static and dynamic characteristics, that we will be discussing first. Then in static there are few desirable characteristics and few undesirable characteristics, that also we will be discussing. After that we have standard inputs to study time domain response, right? ये थोड़ा topic आप पहले study कर चुके हो. Once I will be discussing about that, I'll explain where you have studied this and how you can relate it with the understanding. Then we have desirable and undesirable dynamic characteristics. So desirable, undesirable dynamic characteristics, desirable and undesirable static characteristics. दोनों बहुत important point है for this discussion. And concept of slope error, offset error. वो error में कुछ categories हम लोग study करने वाले हैं. It is actually content of your unit 2, right? So I have just covered them as a table of content, but these points are there in your unit 2. So we have discussed about basic understanding of transducer, and now we are moving about now we are going to discuss about understanding of different static and dynamic characteristics. So this is the table of content. Now I'm going ahead. First of all, by the name you can understand what is the meaning of static and what is the meaning of dynamic. So static characteristics ऐसी characteristics है which are not varying with time, right? So mostly remain constant or varying very slowly with reference to time of an instrument. Those are called as a static characteristics. So mainly they are steady or mainly they are varying very slowly. So that's why we are considering them as a static characteristics. Second जो category है, that is a dynamic characteristics. And dynamic characteristics, they will be changing with time rapidly. So they will have a variation over the period of time, and that variation will be very fast, right? So that is called as a dynamic characteristics. Am I clear with both the terms static and dynamic characteristics? Please write in chat box. Okay, great. So now we can move ahead. Now in static characteristics, there are few desirable static characteristics. As I told you about desirable and undesirable. The desirable means which we want to achieve or we actually want, right? So as we know that there are different terms such as accuracy, precision, sensitivity, then repeatability, reproducibility. These are the desired static characteristics. right? We have not discussed till now about exact definition of these terms, but already you know that accuracy should be high, precision should be high, right? So these terms already you are knowing somewhat in a general understanding, but we'll be studying with reference to its definition as well as some example. So static characteristics may these are the desired static characteristics. So we should understand that accuracy should be high, precision should be high, sensitivity should be good, repeatability and reproducibility should be good, right? So these are the static desired characteristics. Now, undesired characteristics we actually want to avoid or we don't want, right? So undesired characteristics are drift, then dead zone. Dead zone also has some categories like threshold, hysteresis, creep, resolution, static error. These are undesired characteristics, and they are specifically static characteristics. I'm explaining each and every term in detail so that you will be getting clear idea. But before that, desired means you want to achieve those, and undesired means you want to avoid those. So these are my list of undesired characteristics. Okay. Now let's start with the first static characteristics, which actually want to achieve, that is accuracy, right? So already we have discussed क्या होता है actually accuracy, कोई बता सकता है मुझे? I have already explained it in previous session, I guess. Introduction session में मैंने बताया.
Closest to the true value.
Very good. Closest to the true value, right? So if your instrument, how close the output reading of the instrument is to the correct value, or we can say to the true value, that is the indication of accuracy. But in practice, we don't. Yes, good. Closeness to the true value. But in practice, we are more concerned about inaccuracy. So we don't present percentage of accuracy, but we represent percentage of inaccuracy, right? So that is basically if we have inaccuracy representation, it is in the range of plus or minus this many percent of full scale, right? So inaccuracy figure you will be getting, and that is more concerning for an instrumentation engineer. So I have taken one example which will give you clear idea what I want to explain. Let's move to the next slide. Okay. Inaccuracy is the extent to which a reading might be wrong and often quoted as a percentage of the full scale reading of an instrument. Matlab, if I go to the technical understanding, I'm not getting an idea because it's kind of there are different terms like inaccuracy, then percentage of full scale, all those things. But if I explain with the example, you'll get clear idea. I've taken one example here. For reference, I'm using a pressure gauge with in the range of 0 to 10 bar, right? Bar is a pressure unit, has a quoted inaccuracy of plus or minus 1%. The pressure gauge data sheet has mentioned that its inaccuracy is plus or minus 1%. So of full scale. So we have reference as full scale. So now you can see here your full scale का जो main scale है उसकी 1% plus or minus, that is your inaccuracy. So the maximum, for example, maximum error to be expected will be here in this particular case. आपको full scale value है 10, 0 से 10. So if you take the difference, it is 10. So 10 का 1% if I count, कितना होगा 10 का 1%? 0.1. So 0.1 will be your 0.1 bar will be your inaccuracy. So here in this particular case, I have range of 0 to 10, and my inaccuracy percentage is plus or minus 1% in full scale. So I can say that my pressure reading may have variation up to 0.1 bar because 10%, sorry, 1% of 10 bar will be 0.1. So that's why I'm telling that my reading will have some kind of a maximum unexpected accuracy. We can say inaccuracy is zero point 0.1 bar. Okay, this means that when the instrument reading is 1 bar, for example, मैं pressure measure कर रहा हूँ and मेरा pressure 1 bar आ रहा है, उसका meaning क्या हुआ कि this pressure may be 0.9 bar or this pressure may be 1.1 bar. So my variation is only possible in 0.1 range. So from that I can say that my reading is 1. So either it is 1.1 or either it may be 0.9. It will be in the range of 0.9 to 1.1. Right. So this much my instrument is accurate. All of you are understanding this example, please write in chat box. Good. So now we can move ahead. Okay. Now another important point is that so it is very important for you to decide the measure. For example, I'm measuring room temperature, and room temperature is varying in the range of 20 to 30 degrees Celsius. And I am having a temperature sensor which is having range 0 to 50 degrees Celsius. Then it may be one case. In second case, I am using temperature sensor with the range of 0 to 200 degrees Celsius. Which one is more preferred for this particular application?
0 to 50 degree.
Why?
Because if it is 0 to 200, there may be more chances of its inaccuracy being more. So we will get
Very good. Your answer is right,
wrong
but how you
reading.
can say this? Your answer is right, perfectly right that the inaccuracy will be more, but how you can say or why you are saying this?
Like because the range is high, if both the
Very good.
sensors
Range is
even have
high, and
1% inaccuracy, then the inaccuracy is less in the lesser range.
very good. So whatever measurement range you have, according to that you have to select the sensor, right? So accuracy जो है वो full scale के reference में है. So if your range is more and you are measuring the lesser range, then it will be having more inaccuracy. So accuracy जो है उससे हमें ये पता चलता है कितना उसमें वेरिएशन पॉसिबल है इंडिकेटेड वैल्यू में, राइट? सो बिकॉज ऑफ दैट रेंज इज अप्रोप्रिएट टू द स्प्रेडेड वैल्यूज बीइंग मेजर्ड. अब आपकी जो स्प्रेडेड वैल्यूज है, जो आपकी मेजरमेंट रेंज है, उसके अकॉर्डिंग यू शुड सिलेक्ट द इंस्ट्रूमेंट रेंज, राइट? इन ऑर्डर टू दैट द बेस्ट पॉसिबल एक्यूरेसी इज मेंटेन इन द इंस्ट्रूमेंट रीडिंग. इंस्ट्रूमेंट रीडिंग जो है वो आपको नियर बाय एक्यूरेट बताएगा व्हेन यू हैव selected instrument as per your measurement spreaded values. Am I clear to everyone? Please write in chat box. Okay, great. Now we can move ahead. So I have taken the same example here. If we, for example, in previous case, we were having pressure range of 0 to 10 bar, and I was using this temperature sensor, but actually in my application, I have variation in the pressure from 0 to 1 bar only. So that pressure sensor will not be appropriate, right? Because it will be having zero point 0.1 bar of error, or we can say inaccuracy, and because of that it will not be able to give me proper reading. So 0 से 1 bar अगर मैं pressure measure कर रहा हूँ, my pressure is varying between this range only, and I am using a sensor with a range of 0 to 10 bar, which is having 0.1% inaccuracy, and because of that your measurement uncertainty will be more, right? So you should avoid this kind of selection. The term measurement uncertainty और इनएक्यूरेसी दोनों एक ही चीज है, उसको कभी कभी मेजरमेंट अनसर्टेनिटी भी बोलते हैं, राइट? सो द थिंग इज यू शुड सेलेक्ट द सेंसर अकॉर्डिंग टू दिस पैरामीटर, right? This is one of the important point which you need to understand with reference to measurement. Am I clear with the term accuracy? Because now we'll be moving to the next term. All of you are clear? Good. Now we are moving ahead. Next term have the precision. Okay. Braj, what is precision?
Sir, suppose I take 3 or 4 readings of something, and that all the readings are in close range. They might not be correct, but they are close. So
Good.
I can say the measurement is precise.
Perfect. Very good answer. But the thing is, you are mentioning here that they are not accurate, but they are nearby, whatever readings you are getting.
Yes,
Okay.
sir.
Good. So precision is the closeness of agreement among set of results, right? So it is closeness of agreement means how close your readings are, multiple readings are. I'm not mentioning here comparing the true value or nearby the true value. I'm talking about multiple measurements and they are close enough, right? Then it is called precise reading. So precision is the closeness of agreement among a set of results. ठीक है. अभी हम इसको और डिटेल में समझते हैं बाय अंडरस्टैंडिंग टू डिफरेंट टर्म्स सो दैट यू विल बी गेटिंग क्लियर आइडिया. एक टर्म मैं आपको समझा रहा हूँ, रिपीटेबिलिटी, एंड इसके जस्ट बाद वी विल बी डिस्कसिंग अबाउट रिप्रोड्यूसिबिलिटी. ओके, so if you understand these two terms, you'll be getting more clearer idea on precision. तो repeatability जो है एक important term है. Okay, just read these lines, then I will explain. I have done some highlight in the slide. Those terms are very important. So repeatability describes the closeness of output readings when the same input is applied repeatedly. First, this first line is important, right? And you can also understand this with the repeatability term. Now I'm extending that with some restrictions. Repeatability describes the closeness of output readings when the same input is applied repeatedly over a short period of time with the same measurement conditions, same instrument and observer, same location and same conditions of use maintained throughout. Okay. So what I'm saying is instrument is providing you same reading every time under same operating condition, same environment, same apparatus or same hardware, right? Same location, then the instrument is repeatable. Okay. Before understanding or discussing about repeatability, let's move to the next slide, that is reproducibility. Now try to read this and try to differentiate. Okay. Reproducibility describes the closeness of output readings for the same input when there are changes in the method of measurement, observer, measuring instrument, location, conditions of use, and time of measurement. Okay. So after understanding these two terms, after actually reading about these two terms, reproducibility and repeatability, the highlighted points you can see that is the main difference, right? So in repeatability, we are having same measurement condition, same instrument and observer, same location, same condition of the conditions maintained throughout. But when we talk about reproducibility, changes in the method of measurement, right? For example, I'm using different method to measure the same parameter, and also I'm getting the same value. That is called reproducible. That parameter is reproducible. Then, with the help of some different measuring instrument, with the help of I'm measuring at some different location, condition of use and time. So I'm changing all the static quantities which I used to keep in the repeatability case. दोनों का difference पता चला सबको? All of you clear? I want everyone's involvement. If you are in the class, I can read your pieces and I can understand whether you're clear or not. But here you will have to respond with chat box. Okay. So now we can move ahead, right? Now, after understanding repeatability, sorry, yes.
Sir, if some device has good reproducibility, can we say it will also have good repeatability?
No, because repeatability is a short duration measurement, a short duration analysis, and reproducibility is long duration analysis. So uh, both are dealing with the measurement, but in different environment or different conditions. So we cannot straight away say that. We have to define both the terms separately,
Okay.
right? So both the terms describe the spread of output readings for the same input, and this spread is referred to as a repeatability if the measurement conditions are constant. So this is the main idea. Measurement conditions are constant in the case of repeatability. And reproducibility if the measurement conditions vary, either operator, either apparatus, either environment, whatever. The measurement conditions are varying, then it is reproducibility. The degree of repeatability or reproducibility in measurement from an instrument is an alternative way of representing its precision. So I was telling you about understanding precision more clearly after understanding these two terms because of this reason, right? So degree of repeatability and reproducibility in measurement from an instrument is an alternative way of representing its precision, right? So there, for example, instrument repeatable hat, I can straight away say that instrument is having good precision. Am I clear or not? Because precision kya hai? Precision is nothing but closeness between repetitive measurement, right? So that's why I can say that if the instrument is repeatable or the characteristics or say measurement is repeatable, then we can say instrument is precise. Am I clear? Good. So now we can move ahead. ठीक. अब हम थोड़ा रिलेट करते हैं एक्यूरेसी एंड प्रिसीजन को. Let's have discussion. Yes, roll number 32. Yes, sir.
सर.
Yeah. आपको जो फर्स्ट डायग्राम दिख रहा है यहाँ पे,
हम्म.
I want to understand with reference to accuracy and precision.
Sir, it is accurate and precise both.
How?
Sir, because it is nearer to the true value and all the readings are nearer to each other. Like
Okay, so
very
the
near.
true value is the center and all the values are
Yes.
nearby that. And apart from that, you are having multiple measurements which are close. So we can say that
Close.
this kind of response,
Is both.
we can say accurate and precise. Good,
Yes.
very good. Next, 59. Yash,
Yes, sir.
your second diagram.
सर सेकेंड डायग्राम में ये जो सारे डॉट्स है वो एक्यूरेट नहीं है बट प्रिसाइज है क्योंकि उनकी जो वैल्यूज है वो मतलब नियरर है बट वो सेट पॉइंट पे उसकी वैल्यू नहीं है.
Good. So it is a precise but not accurate because there is a
Yes.
huge error, right? After the
Yeah.
center says there is a distance. It's not precise.
Yes, sir.
Sorry, it's not accurate, it's precise. Good. Next, roll number 60. Aryan.
Sir, it is accurate but not precise.
Third case.
Yes, sir.
Good. Why you are saying that?
Sir, because it is closer to the set point.
Yes.
And the values are not close enough together.
Yeah. So there is some.
With certain variation.
Yeah. So because of that, we can say it's not precise. Okay. Last case, 56 number.
Yes, sir. Sir, it is precise, not accurate. The values are not close. They are not. They are not close to each other. So it
So
is
what you
not
are
accurate.
saying?
So it is precise, not accurate.
Not accurate, not precise. Or
No, it is
precise.
precise, not accurate.
Why you are saying it's precise?
So the values are close enough.
Values are close enough. In fourth case, I'm asking about fourth case, last diagram. This one. My mouse is, my arrow is visible. Cursor.
Yes, sir.
I'm talking about fourth case.
So they are not accurate. The all dots are not in the accurate. So we can say that.
And what about precision?
Hello.
What is precision according to you?
So the close value that are not accurate but similar means.
I'm not understanding
Hello.
what you want to. I'm not understanding what you want.
They are not accurate means the range is from.
Yeah, they are
I
not
have taken
accurate. What
four
about
values.
precision?
Yes, I have taken 4 readings and they are close enough, like 26, so 25.9, 24, 25.8. So they are not accurate perfectly. They are precise, somewhat like that.
Actually, answer is not right. Rule number 50 should fourth case.
हेलो
Yes.
सर वो लास्ट केस ना
हाँ.
सर एक्यूरेट भी नहीं है और प्रिसाइज भी नहीं है
Precise के लिए what should be there? There should be closeness of the values.
यस
Right? True values अगर it is nearby or it is very close, then it is accurate. But when there are multiple measurements, in the second case, you can see they are nearby, but they are not close to the true value. And what we can say, they are precise but not accurate. In the third case, you have seen that our true value and our measurements are also nearby, but they are not. The consecutive values are not nearby. Right? There is some difference. So we can say it's not that precise. But in the fourth case, you are not having multiple measurements nearby as well as not near to the true value. So we can say it's not precise as well as not accurate. Am I clear to everyone? Okay, good. So these were the four cases we were discussing. Right? So according to that, you need to differentiate between these two terms. अभी मैं आपको कुछ चीजें आई एम गिविंग यू इन होमवर्क विच यू नीड टू रेफर बिकॉज आपने कहीं कहीं वो चीजें स्टडी की हुई है. एक टर्म आप नोट डाउन कर लो, स्टैटिक एरर. राइट? स्टैटिक एरर, दिस टर्म यू हैव रेड. कहाँ स्टडी किया, याद है किसी को? अभिषेक, यू नो व्हाट इज स्टैटिक एरर?
Sir, the measurements error that we get.
मेजरमेंट है. ओके, रोल नंबर 54 उन्नत. स्टैटिक एरर टर्म यू नो?
Sir, the error we get again and again by taking the values, constant error that we get.
Constant error we get. I am asking you this term because you will also have this in static characteristic. There is understanding about static error as well. So आपको समझना है, it's actually undesirable characteristics. But आपने already study किया हुआ. Zero error. Gaurav is saying zero error means
कंट्रोल सिस्टम में पढ़ा दिया.
हाँ, कंट्रोल सिस्टम आपने ESS पढ़ा था, राइट?
यस सर, ESS
ESS क्या होता है?
स्टेडी स्टेट एरर.
हाँ, स्टेडी स्टेट एरर क्या था?
मतलब द टाइम एट विच द मतलब deviation of the output when it has reached its final states when t tends to infinite and the input is मतलब deviation दोनों के बीच में सर when the t tends to infinite.
Actually, there are two types of error, static and dynamic error. Static error जो है that is kind of ESS. आपको खाली समझाने के लिए मैं भी बता रहा हूँ. So ESS is nothing but steady state error. The error remains in the response, or say the error present in the response after transient has died out. Means आपका oscillation जब खत्म हो जाएगा, तो जो error final बचेगी response में, that is a static error. We can say steady state error. Dynamic error क्या है? जो oscillations आएगा उसमें you will be having error which is changing with time, right? SP minus PV जो है, एक्चुअली यहाँ पे हम वो टर्म यूज नहीं कर, आपको रिलेट करने का ट्राई करवा रहा हूँ. आई एम जस्ट ट्राइंग टू मेक यू अंडरस्टैंड दैट आपने जो रिस्पॉन्स, स्टेप रिस्पॉन्स और वो सब स्टडी किया है, उसमें आप एरर टर्म पढ़ चुके हो. यहाँ पे भी हम स्टैटिक एरर के बारे में डिस्कशन करने वाले हैं. सो आई एम जस्ट ट्राइंग टू मेक यू रिलेट विद दैट पर्टिकुलर टर्मिनोलॉजी. दूसरा यहाँ पे पॉइंट भी था जो मैं आपको रिलेट करके समझाने का ट्राई करूंगा. दैट इज जस्ट अ मिनट, लेट मी ओपन द कंटेंट. थर्ड पॉइंट यहाँ पर जो है, दिस ऑल्सो यू मे हैव स्टडीड, that is a standard input to study time response. And inputs to study time domain response. ये जो है, ये भी आपको you have you studied this?
Which one sir?
Standard inputs to study time domain response.
Yes, sir.
हाँ स्टडी किया है।
कंट्रोल थ्योरी में सर,
कंट्रोल सिस्टम में
थर्ड
क्या
सेम
था,
में।
कुछ आइडिया है?
हाँ सर, एक सिस्टम को टेस्ट करने के लिए टाइम टेबल में कुछ स्टैंडर्ड इनपुट सिग्नल्स होते हैं, जैसे स्टेप इनपुट, रैम, साइनोसॉइडल, पैराबोलिक, उन
गुड,
सब पे हम स्टडी करते हैं।
यस। तो
सर
हम लोग उसे बोलते थे स्टैंडर्ड टेस्ट सिग्नल्स, इफ यू रिकॉल।
यस सर
यस सर।
सो ये जो मतलब कुछ जो टर्म्स है आपने ऑलरेडी पहले कहीं स्टडी किया हुआ है, आई एम जस्ट ट्राइंग टू मेक यू फैमिलियर विद इट। तो ये जो है टॉपिक स्टैंडर्ड इनपुट, टाइम डोमेन रिस्पॉन्स, और दूसरा मैंने आपको एक एरर के बारे में बताया। ये दोनों चीज आपको होमवर्क में एक बार रिवाइज करना है, राइट? आई विल एक्सप्लेन द टर्म्स ऑफ टेंसेस एंड ट्रांसड्यूसर्स, बट द थिंग इज आपको थोड़ा ओवरव्यू रिलेशन यू विल बी एबल टू अंडरस्टैंड, right? So we had the discussion on accuracy and precision today, and in that also we discussed about repeatability and reproducibility. So we will have further discussion in the next session, but before that आपको ये जो टॉपिक जो मैंने बताया था एक बार रिवाइज करके यू हैव टू कम इन द नेक्स्ट क्लास, बिकॉज वी विल स्टार्ट विद द क्वेश्चन आंसर, देन वी विल मूव अहेड। ओके?